All right, so next section, what we are going to talk about is simple interest. We'll talk about personal loans. What we'll do, I guess, next week when we come back is then we'll talk about how to calculate a car payment, if something like that, or if you go to like Home Depot and you buy a refrigerator and you're going to have a payment for that. We'll talk about credit card, how credit cards calculate your interest, and how they tell you what your minimum payment is going to be, because it's useful to understand what lies behind all of this, because you're using all of this stuff. So you should know what's a good way to use it and what's not a good way to use it as you go through. So it all starts with us talking, though, about simple interest. So the amount of money on which interest is charged. So the reason that if you read through the book talks about borrowing money, but this is also true if you put money somewhere and you're letting somebody else use it, like if you make an investment or if you put it in a bank. The reason you get interest when you put your money in the bank is you're letting them use it for other things, so you get money back. So the amount of money that happens with is called the principal. Principal in this situation is spelled with the P-A-L. Okay, I believe. I'm 92% sure. Okay, so the amount of money that you either borrow or the amount of money that you put in the bank, that's called the principal. And so the interest is the charge to use somebody else's money. So when you take your credit card and you swipe and you end up paying some interest, the reason you're paying interest is because you are using somebody else's money in the short term. Again, when you put your money in the bank, the reason you get interest is you're letting the bank use that in other ways so that you get paid for that. So calculating interest based on the total amount based on the total amount for the entire time is called simple interest. So that's different than the interest that you would calculate, for instance, in a bank account or in an investment account. It's different than the interest when you're on your credit card that doesn't, you get charged periodically the interest. In simple interest, you set out the terms. I'm going to have the money for this amount of time. The interest is all calculated up front and everything is set in stone. So simple interest is given like this. So this is something you will need to remember for the test. I'm not going to give you this formula. The simple interest formula goes like this. The interest that you either earn or are charged is equal to the principal times the rate times the time. So the principal is the amount of money that you're borrowing. The rate is the percentage rate times time. And so abbreviated, this is I equals PRT, PERT. Okay, so the banker's rule, took me a second because there's two rules we're going to talk about. The banker's rule, as we're going through and we're doing calculations, says the following. The banker's rule says that a year is going to be 360 days. Oop, this pen is not writing great for me, sorry. A year has 360 days, and a month, unless you're given the number of days, if you're just told that you're borrowing money for a month has 30 days. Okay, so that's the banker's rule, because bankers like to keep things round. And as it happens, the banker's rule works in the banker's favor because everything always works in other people's favor. So that's just a principle of life. Okay, so here we go. Example one. My first example right here says Sherry, she needs to borrow $6,200 to replace the roof on her house. So she must live in Florida. From her credit union, she obtains a 30-month loan with an annual simple interest rate of 5.75%. So we're going to do two things for Sherry. We're going to help her calculate what's the charge for her to use this money for 30 months. And then we're going to determine the total amount Sherry is going to pay the credit union at the end of the 30 months. So we're told right off the bat that, sorry? I froze it. Thanks for letting me know. Now I've unfroze it. We unfrozen? Okay. Sorry about that. I don't have my glasses on. I thought I hit the, so it would stop focusing. But anyway, sorry about that. So Sherry needs to know how much interest is she going to be charged. So this is just straight, simple interest. So the interest that she gets charged is the principal times the rate times the time. The reason I chose this example is I just want to make the following point. We are told that the interest rate is an annual rate. So whatever the interest rate is, if it's an annual interest rate, which almost all of them are, okay, or if it's a daily rate, which if you have your credit card, a lot of credit cards are given in a daily interest rate, or if it's a monthly interest rate, your interest rate and the time has to agree. Okay, so since this is an annual interest rate, my time is going to have to be in years. If it's a daily interest rate, your time has to be in days. Okay, and so just make sure. If you're not told, like in a lot of the problems, I don't tell you what the rate is, assume it's an annual interest rate. Okay, so the interest is going to be the principal times the rate times the time. So Sherry is going to borrow $6,200. That's the principal. The rate is 5.75%. So now we're going to draw back on our knowledge from the last section. What is 5.75% as a decimal? Don't forget to move that decimal 2 places to the left. Now here's where we have to be careful. It's an annual interest rate. I gave you 30 months. The loan is 30 months. So what I have to do is I have to convert 30 months to years. So how many, here's a nice question to keep you confident. How many months are in a year? So how many? Let's try this again. It's just 12, not 24 months. You're confusing how many hours are in a day, but that teaches me to assume, though. I thought that was going to be the easiest question of the day. Okay, there's 12 months in a year. Okay, so every 12 months makes a year. So what do I have to do with this 30 in order to make it into years? Yeah, so over here, I'm going to have 30 divided by 12, and I'm just going to put right here for your notes that this is years. Okay, you don't have to, like when you're doing a problem for me, you don't have to write that word years there, but I'm putting it so that later when you're reviewing your notes, you understand why we had to divide by 12. And in case you still don't understand, I'm going to repeat this because this is probably the trickiest part of the day. This interest rate is an annual simple interest rate. That means that that's the amount of charge you get every year. So my time down here has to be in years. All right, once you've done that, it's basically just a calculator problem. So I'm going to take all that. I'm going to throw it into my TI-30 calculator right here. And so I've got 6,200 and then times 0.0575 times 30. And then I'm going to take that and I'm going to divide it by 12. And that turns out to be 891.25. When you're dealing with money, we will always round to the hundredths place. That's the cents place. Okay, so I do want the 2 decimal places. The credit card company wants the 2 decimal places. They want all those pennies. You can rest assured on that. Okay, so that's how much money Sherry is going to have to pay to keep that money for 30 months. That's the A part of the problem. The B part of the problem says determine the total amount Sherry has to pay back at the end of the 30 months. So the B part is just this. She started out with $6,200 plus the $891.25 that she got charged on top of that to use that money. And so then that turns out to be $7,091.25. So the next few problems we do are just here to reinforce the simple interest formula. Okay, so whatever questions, comments, concerns you have about this, let me know. Exercise 1 is very straightforward. I didn't even take the time to make up a fake problem from it. I want you to use this information to calculate the simple interest. The principal is 2,500. The rate is 3.875%. Notice I didn't say whether it was an annual or a daily or a monthly, so assume it's an annual rate. And then the time is 9 months. All right, so all I'm asking for is the interest. It's just a plug and chug problem. But if you're having trouble understanding where any of these numbers come from, ask any question you need to ask. Okay, that's the important thing for today. So the interest is the principal, which I gave you is $2,500. The rate is 3.875%, so that's 0.03875. Don't forget to change those percents into decimals. And then the time is 9 months. Well, once again, I gave this problem to reinforce that concept from the previous one. This is an annual interest rate because I'm not told otherwise. So my time needs to be in years. These have to match. And so that means 9 months is 9 parts out of 12 of a year. Okay, so don't forget to divide that by 12 to make it into years. So once you've done that, that's the hard part to the problem I would expect. Once you've done that, it's just popping it into the calculator. So 2,500 times 0.03875 times 9 divided by 12. That turns out to be 72 point, and a lot of decimal places we're going to round to the cents. So 72.66. That's all I wanted on that problem. You didn't need to then give me the total amount that would be owed later. We're just practicing this new formula that you've been given, the simple interest formula. So exercise 2, same thing, just different constraints. Again, this time though, I've given you the time in days, okay, and the interest rate is in years. So make sure you divide by the proper thing. Okay, I'm going to leave it to you to figure that out. We'll talk about it in just a moment. Okay, so I'm just going to plug and chug. Again, if you have any questions are great. So the interest rate is not the interest rate, the interest that I have to pay is the principal, which in this case is $6,742. I was feeling feisty and didn't give a round number there. The rate is 6.05, so 0.0605. Again, I'm not told that that is a daily or a monthly rate, so I'm going to assume it's a yearly rate. So then my time has to be in years. My time is presently in days, so I'm going to take that and I'm going to divide by, now some of you might have divided by 365 and I get it because that's how many days are in a year, but remember, banker's rule, the banker's rules, we're going to divide by 360. And here goes when I do my interest. So I've got 6,742. Then I'm going to multiply that by 0.0605. Then I'm going to multiply by 90 and then divide by 360. And that turns out to be 101.97 when I round to my cents place. Yes. Yeah, that's why the banker's rule is the banker's rule, because basically that's 1/4. The 90 days out of 360 is 1/4, and that's why they used 360. That's why 30 days are used each month. So if you had just said, oh, 90 days is 3 months by the banker's rule, so 3 out of 12, same thing. Yeah, great question. Any other questions before we continue on? Okay, then do exercise 3, just one more. Again, we're just practicing this new formula because you do have to remember it. So we're locking it into long-term memory. Okay, so in this one, somebody is obtaining a simple interest loan to start a business. They borrow $7,500 at an annual rate of 3.5%, so 0.035. This time I gave you, this was the most straightforward one of the bunch. I gave you the time in years, so you don't have anything to do with it's an annual rate. I gave you years, so we're all set. So it's 7,500 times 0.035 times 3. That turns out to be $787.50. All right, before we flip the page, did anybody get something different that we have to talk about? Oh, did I ask for more? Yes, look at me trying to just quickly go through the rest of the problem. So yes, so then how much will this person have to pay back? So the 7,500 plus the 787.50 is this right here. 8287.50. Great job, great work. Any other questions or observations before we go to the next page? All right, boom, here we go. So on the next page, my next example, again, we're still going to do each do a couple more problems with simple interest formula. This one, example 2, I've asked something slightly different. This time we know how much interest we're going to be paying, but we want to know what is the interest rate that we've agreed to. So Joe is borrowing $850 from a friend. Probably shouldn't do that, with an agreement that in 9 months he would repay the money plus $51. What's the annual interest rate that Joe agreed to? Okay, so Joe didn't read the terms and conditions of this simple loan from his friend. So here we go. The interest, I'm just going to write down the formula. Interest is principal rate times time. So I'm going to plug the appropriate number in the appropriate place, and then we'll figure out what to do. So this time I am told the interest is $51, so 51. The principal, Joe needed to buy something, so borrowed $850. The rate is what we're looking for, we don't know. And then time, well, again, we actually are told that we want the interest rate as an annual rate, so my time has to be in years, so that's going to be 9 out of 12. So on the right side of the problem, I'm just going to do a little multiplying. I've got 850 times 9 divided by 12. That's going to be 637.5. And again, just a little bit of basic algebra here for us. If I have 637.5 times R, and I've got to get that 637.5 to the other side of the equation, what am I going to do to both sides? I'm going to divide. Yes, thank you very much. So this is going to give me R, 51 divided by 637.5. Turns out to be 0.08. So one more quick thing. That's not a percent. I want to write that as a percent. So to turn that decimal into a percent, I move 2 places to the right. And so that becomes an 8% annual interest rate. So do the same thing for Gilbert in the next problem. What's his annual interest rate? right, let's see how you did. So we know this time that Gilbert, he borrows $240. He's going to pay back $288. So I didn't tell you explicitly how much interest, but you can figure out how much interest is this person paying on their little loan. What'd you say? A little bit more. 288 minus 240 is $48. Okay, so the amount of interest is the amount that's being paid back at the end minus the amount that was borrowed, which was $240, and that turns out to be $48 of interest. So just trying to make sure that I'm going through different style problems so that you see a little bit of everything you're going to see on your homework, so that there's no mysteries or no reasons for you to get angry at me. And so here we go. My interest is 48. My principal is 240. Again, we're trying to find the interest rate. Gilbert borrows this money for 30 days. This is an annual rate, so it's 30 out of 360, or 1 out of 12 if you already did the reducing and saw that 30 was 1 month. So I'm just going to go ahead and simplify the numbers on the right. So I've got 240 times R times 1 over 12. I believe that's going to be 20 times R, but if I've done my arithmetic wrong, please feel free to let me know. And then when I divide both sides by 20, 48 divided by 20 turns out to be 2.4. So the interest rate is 2.4. Now that's not a percent, that is a decimal. And to make that into a percent, I've got to move my decimal 2 places to the right. So Gilbert, as you would when you go to the pawn shop, is getting not the best interest rate. Questions, comments, concerns? Okay, one more. Again, just making sure. I'd rather do too many to practice this than too few, because this is kind of foundational. So go ahead and do exercise 5. Same sort of setup. So on this one right here, I don't need to do any calculations for really anything. It's all pretty straightforward. So the interest is $343.20. That's equal to the principal, which is $16.50. The rate is what I'm looking for. I've been asked to figure out what the annual rate is. So I need my time in years. And the good news is my time is given in years this time. So less work for us. So on the left side of this problem, I'm just going to do that multiplication. 1650 times 6.5 turns out to be 10,725. And then I'm going to divide both sides by that 10,725. And I get that the value of R is equal to something. .032. It's nice that that worked out. It's like they planned in advance when they made that problem. 0.032, and then I convert that to a percent. That's 3.2%. Okay, I'm going to pause here because we did a whole bunch of problems just back to back to back. Are you doing okay? Okay, I don't want you to be shell-shocked. Just want you to feel at ease using the simple interest formula. So far, so good? Because what remains, we're again going to still be using the simple interest formula, but we're going to be using it as part of a larger problem. Okay, so if you're comfortable with the simple interest formula, you're good to go so far. Okay, well then the other thing for the day, so simple interest, the first type of kind of real world thing we're going to talk about is what's called a personal loan. And making payments on that. So there's a rule that came about because of a Supreme Court case. I don't know the year of this. It's called the United States Rule because they were really clever at naming it. So the United States Rule says that if a partial payment is made on a loan before its due date, interest is first calculated on the principal from the first day of the loan. So apparently there was some issue. I don't know the background of this. Apparently there was some issue. I don't know if people wanted to make a partial payment and weren't allowed to by the banks, or I don't know if they were trying to do something goofy with the interest. So what happened was the Supreme Court said if like, for instance, if you borrowed $1,000 and halfway through the loan you want to pay $400 on it to pay down the principal, that what you do is at that point you pay interest on the full 1,000 at that point up until the time you're making the payment. And then going forward, you only pay interest on what's left. Okay, so seems to make sense, but you know how these things go. People on both sides of it are greedy, and so somebody was greedy somewhere. So before we do a problem, I've got two for you to do partial payments. We're going to just make sure that we can calculate how many days there are. So if you want to, on the last page of this, I've attached a little. It's not really a calendar. What it is it tells you what number day of the year every day is. Okay, so you'll need this for your homework. It's in the book, or sometimes they put it on my math lab, but I printed you out a copy so that it'd be nice and accessible. So if you want to tear that off so you can have it at the ready. So example 3, we're just going to get used to this chart before we talk about partial payments. So example 3, it says determine the due date of a loan made on April 7th if it's for 180 days. Okay, so I'm going to go over here to my page, and I see that April 7th, it's already been pre-circled for us, but I'm going to circle it again. April 7th is the 97th day of the year. So now we'll take our calculator. What do I get when I add 180 to 97? 277? So now let's look up what day is the 277th day of the year. And oh, it was also kindly circled for us because this was the first example from the book. So here we go. So that date is October 31st. No, I'm sorry. It's October 4th. I'm reading the chart wrong. I'm having quite a day today. Sorry, it's October, and then over here on the left, 4th. Okay, so that is the answer to that problem, October 4th. The other way to use the chart, it's very similar. It's not really any different. I want to know the number of days from March 15th to November 18th. March 15th to November 18th. So here we go. I'm first going to, it doesn't matter what, March 15th. So the 15th day of March is the 74th day of the year. I'm circling that. And then my short-term memory has already failed me. November 18th is the other day. So the 18th day of November is the 322nd day of the year. Everybody finding those values? And then to get how many days are between them, it's just a simple subtraction. So 322 minus 74 in my calculator gives me 248 days. Everybody clear on how to use that chart, despite my But my bad using it myself, the first example. Okay, then just real quick, again, just to verify that you're okay with it. Exercise 6, I've given you 3 problems. You might need a little help on the C problem. So if you don't quite know how to use the chart for the C problem, that's okay. I'm here to help you, but at least do the A and the B problem. All right, the first problem is April 18th to November 11th. So April 18th, I'm in my fourth column. April 18th is going to be the 108th day of the year. And then November 11th, second to last column, the 11th row is the 315th day. So to get the difference, it's 315 minus 108, and that is going to be 207 days for that particular problem right there. Anybody get something different that we need to talk about? Okay, the next one says February 14th to December 25th. So Valentine's Day to Christmas, I guess. February 14th is the 45th day of the year. And then December 25th is going to be the 359th day of the year. So when I subtract 359 and 48, I end up with 311 days.
Was it 45?
Exactly, that's what I said. 359 minus 45 is 314 days. Yes, great job. I should probably go back to bed. I think I need a nap or something today. Despite my terrible condition today, are we doing okay? Yes, if you're learning today, then you really know it, that's for sure. The last one, okay, so what happens on the last one, the reason I said you might need a little help with this one is because we start off at August 24th and then we go into a new year. Okay, so what we're going to do here is this. August 24th, when I go to my calendar, August 24th is the 236th day. Then May 15th, I'm in a new calendar year. So the May 15th is the 135th day of the year. But here's the problem. This number is now smaller. So when I subtract, I'm going to get a negative. So that's a problem. So here's what we're going to do. We're going to treat it like it's a modular system. We're going to get what's the same congruence class. What's the next congruence class for the next May 15th. So what I'm going to do is I'm going to add 365 to that. And so when I add 365, I get 500. So if we're looking at this as a year, we started out at day 1, and the first day, the August 24th, was 236 days away from day 1. So then the next May, when I go around the calendar year, the next May is going to be 500 days from that original day one. That's why I added 365, because we've gone into the next calendar year. And so now when I subtract those two values, I have 500 minus 236. Since I am not doing good thinking, I'm going to make sure I do this in the calculator. That's 264 days. So if you're doing dates that go beyond the end of December 31st into the next year, you're going to add 365 because you're in the next calendar year. Yeah. So what you did is the same thing I did, but you did it on the other side. You found the same congruence class for that negative number, okay, if it was a modular system, because remember, modular systems repeat, and so the days of the year here repeat every 365 days. So you did, just like the examples we did of modular arithmetic, you did the subtraction like normal and came up with that negative value. And then you said, okay, what congruence class is this? And that's how you got the value. Yeah, it works out that way too. Great to bring that up. Any other questions before now we're going to use this in our next problem? So here goes. All right, here's my last problem for the day. And then I've got, you're definitely going to do, we're going to skip exercise 7. Exercise 7 is just a simple interest problem, but using the table to figure out the time. But I just want to make sure we have enough time to cover the partial payment problems that we have. In fact, while you're working your example, I'll go up and I'll fill in the work for that, and you can check your answer later. All right, so example 4. So we've got Mrs. Panic. She's a teacher who on June 1st took out a 180-day loan of $750 to attend a conference. Her interest rate is 10.5%. With reimbursement money from work, she makes a partial payment of $350 on August 1st. Okay, so here we go. First thing, what's the original due date of the loan? So she took out her loan on June 1st for 180 days. So I'm going to go to my page. June 1st is the 152nd day of the year. When I add 180 to that, that's the 332nd day of the year, which is right down here. And the 332nd day of the year is November 28th. So her loan is due on November 28th. So now what we're going to do is we're going to determine the interest and the new balance of the loan on August 1st. So again, just to summarize, she borrowed $750 on June 1st. On August 1st, she was flush with cash, so she decided to go ahead and make a payment. And so she's making a payment before the due date of November 28th. So we want to see what the interest is. So this is the B part. So let me do my work right here, the B part. The interest that Mrs. Panic owes is the principal, which is $750, times the rate, which is 10.5%, so 0.105, and times the time. Okay, so now what we need to do is we need to figure out the time that's gone by from June 1st to August 1st. So June 1st to August 1st, I'm looking at the table. June 1st, again, was the 152nd day. August 1st is the 213th day. So 213 minus 152 is equal to 61 days. So 61 days, this is an annual interest rate. Don't forget the banker's rule. So it's 61 out of 360. Everybody with me? I know I just did a lot of things. I don't want to go too slow if you're fine. I don't want to go too fast if you're not fine. Okay, now I'm just going to pop this into my calculator. So you have some time to decide if you're fine or not fine. So 750 times 0.105 times 61 divided by 360 turns out to be 13.34375. So this is money. So this is 13.34, $13.34. Mrs. Panic owes in interest. Yeah.
When do you get the 51?
The what?
The 51.
The 61. The 61 came from the number of days from June 1st, which is when Mrs. Panic took out the loan, and June 1st is the 152nd day of the year. And then she's making this partial payment on August 1st. And August 1st, I see from the chart, is the 213th day of the year. And so when I subtract those, that means 61 days have gone by. Okay. So in those 61 days, Mrs. Panic has accrued $13.34. So here's the new balance on August 1st. The new balance is this. She borrowed $750. Then she accrued $13.34 of interest. And then she made a partial payment, so subtract $350. And when I do that, that means the balance at this point is $413.34. That's the B parts of the problem. All it was simple interest, but now the new kind of the new facet of this is being able to figure out the days using the chart between these different dates. So then the C part to the problem says, okay, as of August 1st, Mrs. Panic is just going to let the remainder go at the present interest rate. So we want to know what does she owe at the due date now? So the due date is November 28th, we saw. So August 1st, which is when she made the partial payment, August 1st was the 213th day. To November 28th. November 28th turns out to be the 332nd day. So that means that she has the money 119 more days. So the interest is this, the principal. The principal is now $413.34. Don't forget those 34 cents. The bank's sure not going to forget them. The interest rate is still 10.5%. That has not changed, so 0.105. And now to get to the due date, she's had the money for 119 days, so that's 119 out of 360. So we're almost done with the problem. 413.34 times 0.105 times 119 divided by 360 turns out to be another $14.35. So then the final amount due is the $413.34. That is the balance after the partial payment was made plus the $14.35. And so that turns out to be $427.69. Okay, so I would like you, I'm going to leave that example up there so you can follow along. Your exercise 8 is essentially the same sort of problem, just different dates and different amounts. So I would like you to do I basically just want you to do the same two things. I want you to figure out what's the new balance after the partial payment has been made, and then what's the amount due at the end of the term. And if you have any question about that process, let me know. I can come to you. I can help you get over whatever block there is.
So if they make the payment on May 28th, that means that begin counting on the 29th for the new day or on the 28th. Thank you.
Okay, so I'm just going to reveal the first part of this. I know these problems are a little bit of busy work and they take some time, but in essence, it's just doing the simple interest formula twice. Okay, I know there's extra steps in there. So the first step for this company, they borrowed $15,000 at 8.25% interest. The loan was for 270 days, which, by the way, if it started on April 3rd, 270 days later is December 29th. So that's good to have kind of in the back of your mind. So they made a partial payment of $6,000 on May 28th. So I need to go through and I need to first figure out what's that new balance then going to be on May 28th. So from April 3rd to May 28th, that's the first part to the problem. April 3rd is the 93rd day of the year. May 28th is the 148th day of the year. That's from the chart. That's 55 days total. Okay. So the interest is $15,000, the principal, times the rate of 0.0825, times the time, which is 55 out of 360. That turns out to be $189.06. So the new balance on May 28th is $15,000 plus the interest, $189.06, minus the $6,000, which is $9,189.06. Now, technically, you didn't need to do this bit for the rest, but I just wanted you to be super clear, because if they took out a 270-day loan and 55 days have gone by, then that stands to reason there's 215 days left. But I also did the calculation just to show you it works out both ways. So May 28th to December 29th, the 148th day to the 363rd day, that's 215 days. And now I'm just going to do the simple interest formula again. So all I've done here is the simple interest formula one time, new balance, simple interest formula again. What's due at the end of the loan? So the interest now is the principal, which became 9189.06, times the rate, which does not change, times the time, which is 215 out of 360. So takes my thumbs a few minutes to do these things. So that turns out to be $452.75. And so then the amount due is the 9189.06 plus the 452.75, and that is 964,181. Yes.
For the proxy, have you get the December 29th for the 3?
We were told that the loan started on April 3rd and it went for 270 days. So April 3rd was the 93rd day of the year, if I read the chart right, which we know is in doubt. And so when I add 270 to the 93, I got 363 days. So the 363rd day of the year is December 29th. So that I had to do a little inferring from the problem. Great question. All right, so we've got just enough time for one more. So again, if you didn't quite get all of that, I understand these problems are a little bit involved, as things tend to get with money. Exercise 9 is the same sort of thing, but this time, just to keep things super spicy, there's two partial payments. So I'm gonna summarize what you're going to do here. So we've got a $5,000 loan is taken out on February 1st for 240 days. We're going to find the amount owed on the due date if a partial payment of $1,000 was made on March 15th and another of $1,250 was made on April 30th. So here's what you've got to do. First, you've got to do what is the new amount from February 1st to the first partial payment, which is March 15th. Okay, I'm going to leave it to you to calculate some numbers. Then you're going to go through, you're going to figure out the new balance on March 15th. Then you're going to have to go from March 15th to April 30th, and you're going to have to do it again. And then last but not least, you're going to do April 30th until the end of the loan, which I don't know that date. We'll have to figure that out. So you have to do this simple interest formula 3 times on this one. So you're getting 50% more fun on this problem than the previous problem. It's a value. So I'm going to give you about 5 or 6 minutes to get going and make as much progress on this as you can. Then we'll look at it together.
taking on the test. You'll put one
No, you have to memorize. Yes. That. I will let you know the things you have to remember. And right now, the thing you have to remember is the simple interest formula. We'll give you that table. There'll be a couple other formulas you have to remember. All right, I'm just going to start talking through it. So again, just to reiterate, and the constraints here, $5,000 was taken out on February 1st. The total life of the loan is 240 days. So I'm just going to call a timeout right here. February 1st is the 32nd day of the year from the table. And then adding 240 days becomes 272. And when you look up on the table, that means the ending date is September 29th. That's where I got that from, in case you were wondering. It's just from the table. So 240 days at 14% interest. So we're going to find the amount owed on the due date. Okay, that's our very final answer. A partial payment of $1,000 was made on March 15th. And another partial payment of $1,250 was made on April 30th. So we just got to go through this process a couple times. So the first thing I asked you to do was go from the February 1st, the date we took out the loan, until March 15th. Using the table, February 1st is the 32nd day, March 15th is the 74th day. When I subtract that, that's 42 days. I'm going to use that as my time. So the interest. So it all boils down to the simple interest formula. I know it's dressed up and there's some other steps that are a pain, okay, but it's just the simple interest formula. The interest is the principal, 5,000, times the rate, 0.14, times the time, which is 42 days out of 360. And you throw that down into your calculator, it becomes 8167. So on March 15th, the new balance becomes 5,000 plus the interest minus the $1,000 partial payment, 4,081.67. All right, we're 1/3 of the way through the problem. Then I summarized for you at the beginning. Okay, now what you're going to do is go from March 15th to April 30th. That's the date we were given for the second. So this March 15th date, this April 30th date, those are given to us. So March 15th is the 74th day. April 30th is the 120th day. When you subtract that, that becomes 46 days. So the interest is the principal, that 4,081.67, times the rate of 0.14, times the time, which is 46 out of 360. And when you throw that in your calculator, and your magic calculator box gives you $73.02. So the new balance is the old balance plus the interest minus the new payment. So $2904.69. And last but not least, with great relief, we head into the third iteration of this. So from April 30th to the end of the loan, which is 152 days, my interest is the previous balance, $2904.69, times 0.14, times 152 over 360. Your calculator gives you 171.70, and then we use that to get the amount due at long last, final answer. So great patience, as you can see, is required. If any of you wanted to be an accountant, I don't know if that changes your mind or not. Some of you might be like, I love just doing calculations. Others of you are like, I want to die. I understand, I want to die. That is not my kind of thing. I am not a detail person, so I have to really look closely at that. So